For the Module 5 Lesson 13 problem set, I'm going to deviate a little bit from the standard plans when using a number line to identify the size of fractions. And really what we're trying to do is we're taking these given fractions and trying to put them on a number line so it makes sense. And to be honest, there is one way that I could go through and look at this denominator and create a split that would show thirds across the bottom. And then go ahead and show 6, and then go ahead and show 12ths, so that I can kind of evenly place them along the bottom of our given timeline. But to be honest, one of the skills that we're going to lend ourselves and push ourselves into is using common denominators. And so when I look at these fractions, I need to kind of figure out what is an appropriate common denominator. And the best thing to do is to look, obviously, to the denominator of our options. So in this case, I have 3, I have 6, and I have 12. And those are the ones that we are trying to find similarities between. I also want to share that I have 1, and 1 I can do a lot with because as long as my numerator and denominator is the same, I can make that happen. Very similar with 2. But I also have this 1/2. So I'm going to have to kind of figure out with all 4 of these denominators, 2, 3, 6, 12, what are common factors, okay? And so I'm just going to come over here real quick, and I'm going to use my denominator for that 1 and 1/2, my thirds, my sixths, and my 12ths. I'm going to start just listing factors. So 2 plus 2 is 4, plus 2 is 6, plus 2 is 8, plus 2 is 10, plus 2 is 12. And I'm going to just pause there because I'm ideally, without having to change this, if everything can add up, repeat addition, multiply into 12, then that may be a good common denominator. So 3 plus 3 is 6, plus 3 is 9, plus 3 is 12. So far, we're in pretty good shape with this 12. 6, 12, and what we just did is we found a common denominator with a denominator of 2 can get to 12, 3 can get to 12, 6 can get to 12, and 12 can obviously get to 12. Now I'll tell you, in some denominators, it is not that easy. There's a concept called cross multiplication that you'll learn in higher level math that may not be the greatest common factor, or the least common factor, least common multiple to find your common denominator. But what I found is I can get each one of these denominators that I pulled from over here to equal 12. Obviously, 17 twelfths, I don't have to do anything because it's already in twelfths. And I want to point out one more difference about 13 from 12 or 11 is you'll notice that the numerator is greater than the denominator. So instead of dealing with standard fractions with a denominator that is set and a numerator that's less than it, you'll notice that each of these numerators are actually greater than the given denominator. So if I know that this one's good, we can leave that one alone. Let's look at the 6. How do I get from 6 to 12? And I know I need to do that times 2, okay? And how do I make up for that? Well, whatever I do down bottom, I have to do up top. So I need to times 11 by 2 as well. 2 times 11 is 22. So that one is ready to go. Now we move over to the thirds, and I ask myself, how do I get this to 12? 3 times 4 gets us to 12. So then, whatever I do down bottom, you know it, we have to do it on top. So 4 times 4 is equaling 16. And the last one I'll just point out is this 1 and 1/2. This is still going to be 1 and 1/2. I could also look at it as 3 halves, because if I added the 1 in, that would be 2 halves. So 2 over 2 plus 1 gives us 3 over 2. Which gives us 1 and 6 twelfths if we wanted a mixed number. 3 halves to get to 12, so we'd have to multiply both by 6, so we'd get 18 twelfths, just so we're talking the same language. This one would be 12 twelfths. This one would be 24 twelfths. Okay, so now what I can do is I can start placing my hash marks, and I know that my I have to get 6 hash marks here and 6 here to equal the total of 12. So we have 1, 2, 3, 4, 5, 6. 7, 8, 9, 10, 11, 12. So going from here to here, that would be 12 twelfths. In the case that it's 1, it would be a little bit larger. So now what I'm going to do is I'm going to take my kind of adjusted fractions, and I'm just going to place them on my number line that now represents a common denominator. And this makes it so much simpler to kind of compare. So I'm going to take A, and I'll just do that in yellow, and find 16 twelfths. So this is 12 twelfths, 13 twelfths, 14 twelfths, 15 twelfths, 16 twelfths. So I'll write 16 twelfths down here. I could also write it as its original form, 4 thirds, okay? I'm going to switch colors just to make it a little bit easier to see, and I need to find 22 twelfths. Well, I know it's going to be greater than 18, so this will be 19 twelfths, 20 twelfths, 21 twelfths, 22 twelfths, okay? And again, this is much simpler now that I know the common denominator. I can also include that 11/6, which again, we said is an equivalent fraction, has the same value, it's just represented in different fractional amounts. And the last one is 17 twelfths. Well, we know that this is 18 twelfths, so this would be 17 twelfths, and whatever it is down below, it would be the same because it's already in that common denominator. So now I can see A is placed right here, B is placed here, and C is placed right here. And I'm going to use that information to help me answer the following question. It says use the number line in problem 1 to compare the fractions by writing less than, greater than, or equal to. This would actually be greater than, less than, or equal to. So 1 and 5/6, okay? 1 and 5/6, is that greater than or less than or equal to 1 and 5 twelfths? Well, if I found 1 and 5/6 and made that 6 into 12, that would be times 2. So 5 times 2 would equal 10. So when using that common denominator, right, we know that this would be 1 and 10 twelfths compared to 1 and 5 twelfths. To find 1 and 5 twelfths, that would be 12 twelfths plus 5, or 17 twelfths. That would be right here. Okay, that's this one. This one, 1 and 10 twelfths, would be the same thing as 22 twelfths, right? The 1 is 12 plus 10, 22 over 12. We know that this 1 and 5/6 is greater than 1 and 5 twelfths. And that brings in that concept of often when we see a larger denominator, we think that it's automatically a larger number. In reality, a lot of times the denominator that's smaller has bigger pieces, which makes it a larger fraction. Not always, but many times. Let's look at 1 and 1/3 and 1 and 5 twelfths. We found 1 and 5 twelfths to be right here. Oh, excuse me, 1 and 5 twelfths is right here, okay? So 1 and 1/3, well, that would be equivalent to 4 thirds, because if I take 3 thirds out and make it a 1, I'm left with 1/3. So let's find our yellow mark, that's right here. Our 1 and 5 twelfths is right here. So we know that 1 and 5 twelfths is actually greater. And all we did here is, instead of it having it in improper form, we have it in mixed number form. That's the only thing that is different here. So moving into the bottom, what you're going to do again is try to find a common denominator. And you're going to see, can 8 go into 4, or 4 go into 8? Yes. Can 8 go into 12? No. But I know that 8, 4, and 12 could all go into 24. 12 times 2, 4 times 6, 8 times 3, okay? And whatever we do in the top, we do the bottom. Whatever we do the bottom, we do up top. So let's continue to kind of talk about this on the back side. So comparing fractions, less than, greater than, brief explanation for each answer. And since I have a lot of writing up here, let's look down here, okay? So let's look here, 5 and 10 as our denominators. Well, to get to 10, how could I get 5 to 10? Well, times 2. So then I need to multiply the top by 2. 7 times 2 is 14. So I also know that 7/5 could be listed as 14 tenths. When I look at 14 tenths compared to 11 tenths, we can pretty quickly tell that 14 tenths is greater. Looking at this example, how do I get from 4 to 8? I know it goes in. Well, 5/4, 4 times 2 will give us 8. So 5 times 2 is going to be 10. And again, another way to look at 5/4 is 10/8, and we know that 10/8 is greater than 7/8. Now, I'll tell you, something you could have checked without even having to go ahead any further is this has a greater numerator than denominator. It's more than 1. This has less than 1. That would be a pretty quick way to tell. Let's look at one more problem. All right, let's look at this 8/12 and 8/4. Now, interesting, this numerator is the same, but the denominator is different. And I have a feeling, as I mentioned before, the greater the denominator doesn't always make it a larger number. Actually, I can tell that 8/12 is less than 1 and 8/4 is greater than 1. So I have a prediction that 8/4 is going to be greater than 8/12. But let's double check. So 8/4, how do I get it to 12ths? Well, I have to times by 3. 8 times 3 is going to be 24. So 24/12 compared to 8/12, I can confirm that 8/4 or 24/12, they're the same thing, is greater than 8/12.